NEB TV, what's trending in science.
Welcome to NEB TV. Today, I'm joined by Tom Evans, who is the scientific director of our DNA Enzymes division. Hi, Tom.
Hi, Dina. How are you?
Good. And today we're talking about applications of DNA assembly. In our Science in 60, Tom will give us an overview about how DNA assembly works. Then we'll hear from some of our customers about how they use DNA assembly. And lastly, we'll show you how DNA assembly can be used to synthesize sgRNA. Are you ready?
I'm ready. This will be fun.
Great.
The discovery of enzymes and the development of techniques to accurately cut, move, and join distinct DNA molecules revolutionized the life sciences. Traditionally, restriction enzymes and DNA ligases were used to cut and join these DNA molecules in a sequential manner. Despite the popularity of traditional techniques, other methods were subsequently developed. DNA assembly, which can be performed using our NEBuilder HiFi products, can assemble linear DNA fragments generated by PCR, restriction digest, or chemical synthesis. These fragments need regions of homology in order to give specificity to the reaction. The process starts when a 5' to 3' exonuclease exposes single-stranded regions on each of the DNA fragments. The newly created single-stranded regions anneal to their complement on a separate DNA fragment. Any remaining gaps are filled in by a DNA polymerase, and the joining is completed when a ligase covalently attaches the newly assembled DNA fragments. Fast, accurate, and simple to use, DNA assembly can be used for a whole variety of applications.
So one thing that I do quite frequently is clone one new guide RNA into the same guide RNA backbone, and it works for that. And the other thing that we do is just make a whole new plasmid. So that will take like 6 or 7 pieces from many different plasmids and stitch them together into a completely new backbone.
Right now I use NEBuilder for actually all of my clonings. These include complex situations when I have to assemble like 3 or 5 pieces into one plasmid, or just even one single piece into one backbone.
I sometimes just put one piece together with a backbone and I just use it with NEBuilder to design the primers because I know it's going to work.
Most importantly, it simplifies the cloning procedure dramatically, and it greatly speeded up my project and saved me a lot of time.
It's incredibly reliable. So because we know it's going to work, it cuts down on the amount of downstream screening that we have to do afterwards.
In some cases, it enabled me to create complex constructs that is almost impossible to create using traditional cloning methods.
With restriction cloning, we would typically pick 8 colonies to screen by PCR and sequencing, but now we sometimes just pick 1 or 2 and can pretty much be sure that we're going to get the right clone.
Personally, I think the feature about NEBuilder that I like most is it makes creating point mutation much easier.
NEB has developed a protocol to quickly and easily change the targeting of a single guide RNA in an sgRNA plasmid or to create an sgRNA plasmid library. The method uses a single DNA oligonucleotide, a restriction enzyme digested plasmid, and the NEBuilder HiFi DNA assembly master mix.
Choose a target sequence or target sequences using a design tool of your choice. Design a single-stranded DNA oligo containing a target sequence flanked by a partial promoter sequence and a scaffold RNA sequence. In this animation, the U6 promoter is used. Prepare the DNA oligo. Assemble the reaction mix by combining DNA oligo, restriction enzyme linearized plasmid, and water. Add NEBuilder HiFi DNA assembly master mix and incubate for 1 hour at 50 degrees Celsius. Transform NEB 10-beta competent E. coli with the assembled product. Spread outgrowth on plate with antibiotic and incubate overnight at 37 degrees Celsius. pick colonies to grow, and purify the plasmid DNA for sequencing. Some traditional methods require synthesis, phosphorylation, annealing, and ligation of two oligos into a digested and dephosphorylated vector. This new protocol, using a single DNA oligonucleotide with NEBuilder HiFi DNA assembly master mix, is a simple and streamlined way to rapidly create specifically targeted Cas9 sgRNA plasmids.
So Tom, thanks so much for joining us today.
Thanks, it was a lot of fun.
Good. And as always, if you have any suggestions for future episodes, please let us know.